All right, we're going to be talking about question 18. Question 18 says, use information about the Earth and its orbit to determine the mass of the sun. So we're going to pretend for a moment like we don't know the mass of the sun. And all we know is stuff about the Earth. What do we know about the Earth? Well, I could know the mass of the Earth. I could know the period of the Earth. That's the time it takes to do one full revolution. I could know the distance from the Earth to the sun. All right, let's figure those out. Mass of the Earth is given to us as 5.98 times 10 to the 24th. Period of the Earth is given to us as 1 year, but we need to convert that into seconds. And the distance from the sun to the Earth is given to us as 1.5 times 10 to the 11th meters. So let's quick do that conversion to figure out the period in seconds. So got 365 days in 1 year. 1 year. 1 day has 24 hours. 1 hour has 60 minutes. 1 minute has 60 seconds. And I'm going to cheat a little bit, only in that I already did this calculation earlier. So the period of the Earth is 3.15 times 10 to the 7th seconds. All right. Now our goal is to find the mass of the sun. Well, draw a little picture. Right. It's not a great sun, but it'll do. Earth travels in a circle around it. And that's the fact that I'm going to use. I'm going to use the fact that it travels in a circle. So I'm going to say the force of gravity is what causes it to travel in a circle. Gm of the sun, m of the Earth, over r squared is equal to m of the Earth, v squared over r. Now, these r's aren't always the same r, but let's confirm. R in a gravitational equation is the distance between the centers, and that is what I know. And this r is the radius of the circle, which, you know what, it works out just fine right here. So we're fine without making any adaptations to the r. Notice that the ME, the mass of the Earth, actually cancels away, so I didn't need to know that number. And I want to get the mass of the sun by itself. So let's see. R squared V squared over RG. One of these radii is going to cancel. V squared R over G. Oh, but I don't have V numbers, I have T numbers, so I need to do a quick plug-in. V equals 2 pi R over T. So 2 pi R over T squared R over G, 4 pi squared R over G over T squared, 4 pi squared R cubed over T squared G. All right. So my grandma would say now we're cooking with gas. So, four times pi squared times the radius is 1.5 E11 to the third divided by quantity. So I have to do quantity because I'm going to be dividing by two things that get multiplied down there, but okay, I want the 3.15 E7 to be squared times 6.67 E negative 11th. Always best practice to check that you typed it in right before you just accept the answer. 4 pi squared r cubed t squared. From what I can see, it looks good. It gives us that the mass of the sun is 2.00 E30 kilograms. And the book says that the mass of the sun is 2 E30 kilograms. Pretty spot on. That's question 18.